My name is Taylor Gerring. I've been working in the blockchain space for 3 years now, which is kind of a long time considering how new a technology it is. And I decided to come up a 2-hour drive tonight to be here and talk to you guys. So, who here has heard of Bitcoin? Raise your hands, please. Anybody? Okay, quite a few. Awesome. Has anybody looked at Bitcoin beyond the token, like the blockchain technology, and what comprises that? Is anybody? Few hands? Okay, so lots of hands for Bitcoin, few for the whole blockchain thing. But that's cool. We're going to educate you guys tonight. And I want to make a case for why is decentralization important for developers? If you're not ideological, you're not like a libertarian anarchist that wants to overthrow the federal money printing system, then why might you be interested in Bitcoin and blockchains? And there's actually quite a few reasons why this might turn out to be interesting technology. So, a little backstory. The first thing here is I have highlighted, this is actually from a Bitcoin block. The first ever block, the Genesis block. And the message there is the Times, 3 January 2009. Chancellor on brink of second bailout for banks. And this kicked off a firestorm that has kind of led us down the path of several years now where we have a whole lot of experimentation beyond this initial idea of Bitcoin. Before I get into all the details, I just want to mention that technology, like anything else, is built on top of other technology. It doesn't come into being out of nowhere. It has to build on math and all kinds of data structures and things like that. So it's important to recognize that blockchains are actually available to us because of, well, the internet for one. Database experiments, SQL back in the 60s and 70s, NoSQL movement, big data movements, all those things contributed to kind of where we got today. Same thing with cryptography, hash trees, PGP, asymmetric cryptography is very important, and peer-to-peer networks. Distributed hash tables allow for like peer finding discovery, and BitTorrent kind of implemented this in the protocol of Cryptography. And that was kind of like the first time that we were super decentralized. Some of the earlier things like Kazaa and Napster had some central points of failure. So Satoshi comes around and he says, governments are good at cutting off the heads of essentially controlled networks like Napster, but pure P2P networks like Nutella and Tor seem to be holding their own. And he recognized this. He recognized there was a need for censorship resistance. And he was very passionate enough to kind of create this Bitcoin idea. So he writes a paper called Bitcoin, a peer-to-peer electronic cash system. In the paper, he actually never mentions the word blockchain. So it's kind of interesting. I'm not sure where the word kind of originated from, but it has a lot of different connotations and meanings for it. But Satoshi does mention chain of blocks. What that really is it's an immutable Merkle data tree. So without getting into super technical details, it's a bunch of hashes that point to other hashes that point to other hashes. It's used in Git, to GitHub, and a bunch of other systems. He decided, all right, if we put this in a certain way with the right kind of incentives, we can produce a permanent ledger that's controlled by no one, and everybody shares, which is kind of a unique value proposition, I think, if you look at traditional database systems, Oracle, MySQL, whatever you use. The idea that everybody can write anything they want is a little foreign, perhaps. So again, the censorship resistance via P2P communication. In the end, he created a coordination system that answers some issues for the Byzantine generals problem and prisoner's dilemma. Finally, I think the most key part of this is basically the protocol governs compliance. The protocol is the software running on all of our computers. And if you do something that's not allowed by this protocol, the rest of the software is just going to ignore you. So this is really interesting because the network kind of lives on its own. It's its own organism, so to speak. It's just on the internet, and it's not Amazon servers or Microsoft servers. It's just peer-to-peer, like BitTorrent. There's another part of this governance, which is the fee system that's involved, and that's to prevent a system of tragedy of the commons, where like no one wants to pay for a road, but everybody wants to use it. So how do you solve that? And you say, all right, well, everybody needs to pay a small fee. because we all share this together. So Bitcoin is born in about 2008, 2009. At that point, it's its first own thing. It doesn't have value. It's not worth hundreds of dollars. It's a weird token that somebody decided to pay 10,000 Bitcoins for a pizza. And that's the first time it had value. Went on the market, and it's got a lot of attention for creating higher prices since then. But we've had a lot of experimentation since Bitcoin. Litecoin was one of the first that experimented with a 2.5-minute block time. Dogecoin has billions of tokens, and they're not super serious about getting to be worth hundreds of thousands of dollars. They're there to have fun, which is kind of cool. There's also Darkcoin, which is kind of defunct now, but it was an attempt at more private transactions. So you have cash, you spend cash today, and it's basically private. No one's tracking the serial number, I hope. So what people eventually saw was, hey, value transfer is really cool, but we can do something besides value transfer. And people started dreaming about innovation in all kinds of industries. And eventually, a kid by the name of Untitled Chapter came up with an idea for this generalized state transition machine. They said, what if Bitcoin wasn't just value, right? But what if it could do lots and lots of things? What if the little code scripting engine running in there wasn't intentionally limited, but rather fully Turing complete, and you could run any programming language you wanted on there? And that's kind of where we ended up at some point. So I have a list of blockchain projects here. This is just a sampling to kind of give you an idea that blockchain isn't just value transfer. We have Bitcoin, and the successor to Darkcoin is called Dash, and they're experimenting actually with governance models where the protocol issues tokens, which are convertible, and those tokens can be budgeted for actually working on the protocol itself. So the protocol pays for its own maintenance and development to continue on, which is a really cool, interesting idea, I think, that goes beyond just the value transfer. There's the processing component, which is Ethereum, which is a nonprofit foundation that I represent. I think the project's super cool, and I'm really happy that they pay me to talk about and code on the project. I'll talk a little bit more about that later. There's attempts at storage. Namecoin was supposed to be decentralized DNS. IPFS is kind of applying the Git data model to everything on the internet in an attempt to get rid of 404 links. So broken web pages might be a thing of the past. There's a few other organizations made safe storage. And even now a company called BigChainDB that's recently come out, they're saying they are a high transaction throughput blockchain database system. I don't know a lot about them, but I want to learn some more. And then even BitMessage have experimented with messaging. So if we just stop for 1 second, we look at processing, storage, messaging. These are all traditional computer components that we kind of use. Bandwidth as the messaging component. So if you think about this, we went from mainframes to like these personal computers, and now we're actually getting to a point where there's a shared computer on the internet. It's one huge global computer, and that's effectively what Ethereum is trying to be, is the world's trusted decentralized computer. She's saying, what? Bitcoin's not only good for buying drugs? That's right. There are lots and lots of things that you can use blockchain technology for. And they have a few key features in common. The big one is, this is huge, it's a database that doesn't update or delete. You can only read from it and create append, basically. That allows you to have this permanence that you don't lose any information, because if you lose old information, you don't know what the current state of things is. We also have non-repudiability, and this is given to us by cryptography. So if you have a key pair that you use to like encrypt your email messages, or even on the new chips on the cards, it uses basic cryptographic properties, which is signing and verifying. So you can sign a message and prove that whoever signed that message, whoever has that private key, actually did sign that message, and they can verify that, which is really interesting for identity applications. And we also have fault tolerance because of the peer-to-peer nature of it, your censorship resistance, and also if you have any sort of partially connected environment, it's a lot cheaper to maintain 80% of 100 nodes kind of partially connected all the time, versus having, let's say, 2 redundant full-time links that you're going for 5 or 6 nines, right, of uptime. So I'm really excited about the mesh resilience aspect of blockchain projects. I have a whole bunch of benefits here. We talked about some of them. Big one for me, I come from a DevOps database background. I hate deploying applications. Developers mostly don't think about production kind of issues. They're like, code, code, code. Here's my app. Great. Does it need a web server? What ports need to be opened up? Those kind of things developers often leave out. So the fact that you can kind of one-click deploy the logic to a decentralized blockchain that lives everywhere, and you can one-click deploy all the static assets to a decentralized storage system that isn't Amazon or Microsoft controlling it necessarily, that's really cool to me. I don't ever have to worry about it again. It's always there. Jurisdictional concerns. So blockchains, because there is no single server that it's running on, you're not selecting a data center in West Virginia or Oregon or Ireland, right? It's kind of everywhere and nowhere all at the same time. If I open up my laptop and I run a program, I'm part of it, but does that make me necessarily here in Orlando, or is it just part of a shared network? And I think Estonia is probably going to be the first place that's going to recognize this. They've already come out and said, hey, we have this e-residency program where anybody can apply, get a digital ID card, and start a business in Estonia, or file your taxes. We also will recognize blockchain as a separate, total independent jurisdiction. So that's kind of an interesting thing, especially when you consider HIPAA compliance and all these kind of regulations that are based on where you're at. I mentioned identity built in, reputation can be shared. No longer does your reputation from eBay have to be independent from your reputation from Amazon, which is independent from Airbnb and Uber. In a future blockchain world, everything's kind of interconnected, so you can share your reputation. And also you can kind of avoid the whole password account situation. Cryptography allows for the signing and verifying, so if you give a user a challenge phrase, they can use their account to confirm, and you are never actually storing a password or sharing secret information in any way. You just use the magic of crypto to kind of like hand-wavy, oh, here's a hash, it's done. So as an application developer, not having to store secret information and be hacked is a really big benefit to me. Auditors, accountants love things like auditability. There is a gentleman who kind of coined the phrase triple entry accounting. If you're familiar with accounting at all, double entry is debits and credits. Triple entry is this idea of having a cryptographic receipt at the end of it, which helps prove it. Censorship resistance and M2M transactions. So B2B is business to business, C2C, consumer to consumer, M2M is machine to machine. And with the Internet of Things, microtransactions, paying for content or Wi-Fi as you use it, machine-to-machine transactions probably will outpace the business-to-business and consumer side. Once your fridge is connected and can tell you when your milk is low and automatically order it from Amazon, we're talking about a different kind of world. So I'll just run through a quick few caveats of the system if you're interested at all. External data is really hard to get in. You can get them in via data feeds into oracles, as they're known. Basically, the system doesn't know anything outside of this. Right now, as well, privacy is a little difficult. You can use some external systems like PGP to pre-encrypt it and put it on there. There's a theory right now called zero-knowledge proofs, or ZK snarks. They might actually allow for privacy on blockchain. And the other one is scalability. We're always looking to increase transactions per second and decrease the time to finality. And what do I mean by time to finality is, in a database system, you have ACID compliance where, if two updates come in, one's going to be applied, not the other, and they're not going to conflict. It's kind of an important property of database systems. And blockchains are what we call eventually consistent. When you make a transaction, it isn't finalized and confirmed right away. In Bitcoin, it takes 10 minutes for one confirmation and longer. Ethereum's doing 15 seconds, and other projects are experimenting with sub-second latency for this finality or confirmation. One last dense slide, and then I'll get to some fun things to look at, I promise. So last thing is public-private consortium chains. If you've heard about public versus private chains and wondered what that is, I have too. Basically, public chains are what we think of when we think of Bitcoin, the blockchain, where people use the coins on dark nets and gambling sites and whoever else knows. Basically, they are secured by these pseudonymous validators. That confirmation time I was talking about, there's a set of validators out there who has to say, all right, all these people are sending out transactions, we need to come to a final ordering and list what the result effectively was. And the validators are incentivized with a subsidy from the protocol to do that work. And there's a couple of systems for that. Proof of work is the one that we use most now. Bitcoin hashing, it's also known as mining. We can plug a box into the wall, it spends a lot of electricity money, and hopefully you get some Bitcoins in the process. Is more or less how it works. Proof of stake is another experimentation, tries to get rid of the whole electricity expenditure, since it seems to be wasteful and maybe less efficient than other systems. That is saying if you stake some value, if you bond that value, make a deposit, you can use that as collateral to say this transaction has gone through and effectively bet on the truth. And there's lots to read about this, a lot of it's theory still. Finally, consortium chains, basically like public blockchain, but instead of having a random set of validators where anybody can participate, perhaps you have a limited set, so maybe JP Morgan Chase wants to be in a consortium with Bank of America, and UBS, but maybe not your local credit union. They could do that if they wanted, and some of them might. But in the end, I think private chains are kind of a fuzzy idea. There's a couple aspects that could be private. Is it the database, the ledger that's there, or is it the exclusivity? Is it privacy through exclusivity versus not having the data available for the public to read? So if you read about private chains, just kind of think about that in the back of your mind. What is private chains exactly? I don't know. So, one more. If you find any of this interesting or boring, you can go online and learn some more. Real quick, let's get into the deep tech stuff. Right now, what supports Ethereum as the processing engine is basically there's a virtual machine, like lots of other languages. That virtual machine is currently implemented in 7 different system languages right now: Python, Java, C++, Haskell, Go, JavaScript, and Rust. There's also partial support in .NET and Ruby. Developers who have taken a look at this technology and like, oh, whoa, decentralization, that's pretty cool. I want to learn some more. My experience is to get really excited and start to dive in real deep and are looking for those libraries and stuff. And that's why we've ended up with 7 languages, despite the fact that the project has only been online for 7 months. And as an idea put into words, has only existed for 2 years. To me, that's pretty impressive. And they work off of a standard, there's a yellow paper that's basically a technical Bible, gives the virtual machine opcodes and basically stack-based register, kind of like CPUs in your computer, but it's virtualized on the internet. You can communicate with the clients either in the direct system languages, if you want to write that, or you can deal with something easy like a JSON RPC, which is transport agnostic. You just hit it with curl and get the data out of the system. But even easier than that, we built something called web3.js, which is a JavaScript library. What does this mean? That means that you can use JavaScript to interact with the blockchain. And sub-components of the blockchain can basically be first-class citizens in your application. So you can deploy a crowdfunding proposal and say, hey guys, if you guys want to have an ODEV meetup for April, we need to put together $200 for pizza and beer because we didn't find any sponsors. You can do that. You can do it on a blockchain. You don't need a server for it. I think that's pretty cool. You also don't need any complicated crypto math. All you just need to know some really basic JavaScript. How basic? Just a couple lines. On the website, there's a lot of information on how you can kind of get started and play with it. But you see here, there's kind of a democracy proposal. There's just a JavaScript function, list proposal 42, tells you what it is, website design, there's some votes for and against, and how long. Set your own vote, send the transaction there. That's it. Just a couple lines. They're interacting with blockchains. There's also an IDE mix that's on the right-hand side here where you can step through the VM, and if you're like super low level and want to like work out some problems, great tool for that. You can also just use your in-browser like Firebug debugger. That's what I use. And then there's also a GUI wallet. If you download Bitcoin wallet or anything like that, I promise you this looks so much cooler. and does the whole smart contracts thing, which I haven't talked about what smart contracts are. We have community charts, graphs, and chain explorers. Neat stuff. In the upper right is this Ethereum network stats module someone wrote, and it kind of has information about the network, where the nodes are, what the block height is, where in the world people are, and so forth. It's kind of fun to watch and stare at for a long time, and then kind of get annoyed for not doing a lot of work. But you know, it's pretty. There's also lots and lots of dApps being developed. Blockchain is not new. It's like all these projects have been in development for years. And this one website, just one website, has 150 dApps, decentralized apps, that are either production now and living on the network, or being developed. You can see at the bottom here, decentralized Twitter, Ether Forum, ETHID. You know, what would be really cool is if every time I use Twitter and Facebook, they wouldn't change the terms of service and then inject some stuff into my timeline that I don't even know what it is, and then they're testing me as user data to see if positive and negative emotions affect how I feel. Like, I don't want that as a user. I'm tired of being the data as the user. I want my data back. In a decentralized system, you let the user keep their own data because, you know, private, public cryptography kind of works that way. And they can select what that data means to them and how it relates to them. So you deploy the app in a decentralized location. The user accesses it through the browser, and you don't have to worry about user accounts. You don't have to worry about reputation. You don't have to build in all these things that, as web developers, we're used to building in. And frankly, I'm kind of tired of building. Now it's free, part of the protocol. So I can have, if you want more information. Before I leave for the weekend, there's also stackexchange.com. There's a dedicated Ethereum Stack Exchange that you're welcome to go do. That just opened up publicly a couple weeks ago. I'm on there answering a bunch of questions. If you're a Redditor, our Ethereum is a great spot. The cool black and green dashboard is ethstats.net. The other screens are from etherchain.org and etherscan.io. There's the Ethereum logo, in case you see that anywhere. It's cool. This is me, Taylor Gerring. I'm the Director of Technology for the Ethereum Foundation. You can find me on Twitter at Taylor Gerring, github.com/tgerring, or blockchainconsulting.expert, where I have these slides available along with some of my other talks, and I have business cards with this URL on it as well if you want to take them. So, questions? Does anybody have a question for me? Yes?
So I got a question about blockchain itself. So the whole point of decentralized apps is that you have all these different people doing the proof of work, and so you kind of spread around this effort, and it's kind of randomized who does the proof of work at any given time, right?
Yeah.
But isn't there a danger that more and more you see consolidation of the people and groups doing the mining? For example, mining pools form, or certain groups just have huge amounts of processing capabilities, and one group or another can take over greater than 50% of the processing power, which kind of destroys the whole system.
Yeah.
Right.
So I mean, there are people have seen that, and you know, basically the question is about proof of work and how there are mining pools with lots of power, and they can collude and change the truth in the end, because the consensus system is only based on what we consider to be a majority truth. So people see this problem potentially of proof of work and maybe too many resources being concentrated in a certain area or a certain nation state like China. Most of the power is there. And this is another reason people are looking at proof of stake. Another thing that I like to point out with the difference between proof of work and proof of stake, proof of work essentially selects in Bitcoin one random person to mint that block. Out of everybody participating, they won the lottery ticket, they can mint the block. I kind of like part of the consortium idea where, well, there should be a few people involved in maybe signing the block result. And proof of stake allows this to be a lot easier because you can have maybe 200 validators out there vying to participate, but select randomly 16 of them. And for me, this is a little bit better because you have 16 people that are incentivized to converge on the truth and create that same information versus one person who maybe could act maliciously. So aside from the energy expenditure, this is another area people are looking into tweaking this mechanism of the blockchain, I'll call it.
So just as a follow-up to that, I read today that a lot of large banks, like there's like 40 banks that are testing their own implementation of the blockchain, and that I saw it was like on Hacker News, and in the comments I briefly read that they, like one of the people were confused because they're not using proof of work. Is that what they're using proof of stake instead? Is that what they're testing out, or is that another kind of?
I didn't see that article. I'm not 100% sure, but I know that for a couple years now, there have been a lot of private organizations interested in the consortium model. It's basically a federated system where they have a few participants and they want either 2/3, a majority, 100%, whatever their threshold is for truth, but they want to kind of collaborate with the member banks so that you can see, at least in financial situations, they have to trade money across borders, and it's just part of the regular course of business, and they want to be more efficient at it. So I think they're interested in it from that point. They don't really trust the idea that anybody can write anything they want to data that's going to be on a system that they own. And I think you can see kind of the business risks there, aside from whatever theoretical purposes you might not like Bitcoin for. So, cool. All right. Thanks for hearing me.